Good morning, friends.
Good morning, ma'am.
Morning, ma'am.
One minute. Excellent. So, what we have discussed, friends, in previous class? Yes. What we have discussed in previous class? Yes. Can you just explain what we have discussed?
Exercise question answers.
Exercise question answers. So I wanted to tell you. So I did not consent. Today I will tell you that exercise part question. Then what are things we have discussed in that lesson? Please explain, one of you. Who will explain? Yes, Santana.
What?
Will you explain what we have discussed? What we discussed in the lesson, last lesson, students? Will you open your mouth or not? Okay. Now we come to the next lesson in chemistry, students. What is that? What is the next lesson in chemistry? What is the next lesson in chemistry, students? Third lesson, structure of the
Atom.
you did not say what you have learned in the last lesson. Hmm? Structure of the atom. So what is an atom? Yes. What is an atom?
Elements are made up of extremely small particles are called atoms.
Okay. Atom. So next is what is that? Charged particles in this lesson. What is the second lesson is structure of the atom. Okay, structure of the atom. So in this charged particles in matter is there. What are the charged particles in matter? For example, what we have discussed of atom. So this is a this is a structure of the atom. There will be positive and negative charged particles and neutrons. What is that? Protons means positive charged body. Protons, neutrons means there is no any charged bodies, and electrons means these are electrons and these are neutrons. So neutrons and protons together we say that nucleus will be structure of an atom. So protons will be having positive charge bodies and electrons will be having negative charge bodies. Neutrons they don't have any charge bodies. Okay, now we come back. Atoms have three types of subatomic particles. Three types means what are that? Protons, electrons, and neutrons. Okay, so electrons are negatively charged. Okay, we recognize this letter E. Okay, and protons are positively charged, and we say that P positive plus. Okay, and neutrons have no charge. They have no charge. Just the represents the letter N, neutron. So the mass of an electron is, what is the mass of an electron? What is the electron is this? The mass means weightage. The weightage of electron is 1 by 1000, 1 by 2000, 1 divided by 2000, the mass of a hydrogen atom. What is that? Hydrogen atom. What is that hydrogen? You know that hydrogen atom. 1 divided by 2000, the mass of a hydrogen atom. Okay, what are the molar mass? And we have discussed the molar mass, right? Atomic number of all elements, right, students? Here, the mass of a proton is equal to the mass of hydrogen atom. So, what the mass is having the hydrogen, no? So, the proton is also having the mass same. And taken as this is 1 is the mass of hydrogen. The mass of a neutron is equal to the mass of a hydrogen atom. Both are same, and it is given as 1 is. So, what is the atomic number of hydrogen, students? 1. Okay. The molar mass is also 1 or 2?
1.
1. Okay. Now we come to the structure of atom. So, you know already what is that atom and what are the characteristics of atom. So, atoms are made up of smaller particles. Okay. They are made up of smaller particles called phase, electrons, protons, and neutrons. So, an atom consists of a cloud of electrons surrounding a small dense nucleus of protons and neutrons. Okay, this is a nucleus which is having the protons and neutrons, and it is the electrons is surrounded. Okay, electrons is surrounding a small dense nucleus of protons and neutrons. So electrons and protons have a property called electric charge. They have property called electric charge is positive and negative charge. They have positive and negative charge. They have a property. So which affects the way they interact with each other and with other electrically charged particles. You know that in the 8th standard or you have learned in the 7th standard, charged particles and uncharged particles. For example, what is that? We say magnet. Do you know magnet, students? Magnet. You know that attracts and another one what we say? So what I said is students? Magnet. Yes? Now you tell me student this position of magnet, is it attract or defect?
Defects, ma'am.
Yes? Now you tell me here negative charge, both the side negative is there. The charge will attract or what happens? It will not attract.
It will not attract, ma'am.
Why it will not attract?
Both are minus.
Both are minus. If both bodies are charged with students, if both the bodies are charged means they will not attract. Okay, there should be one body should be charged and another should not be charged. Okay, then only it will be attracted. For example, opposite directions here, opposite directions. You say that, okay, opposite directions attract each other, right, students? So north to south they attract. South, south, north, north, they will not attract each other. Understood, students? Like that, you know the battery we connect to the wire, students, battery, you know. So you think it is a cell, so which we use to connect the wires to produce current. Okay, so here it is the positive and it is negative is there. If the both of the positive is there, what happens? Yes, you know, whenever we connect the wire, there will be two wires. One we connect to the positive, one we connect to the negative side. Okay. Do you know this? So we say the positive charge and negative charge. So here we can say the both the charge bodies are there, means they will not attract. Okay, if the one body should be charged and another should be uncharged body, they attract each other. Okay, they interact each other with other electrically charged particles. Now we can see the picture shows electrons, neutrons and protons, what we say. So protons and neutrons comes in the middle of the electron, comes in the middle of electrons, center point of this electron. Okay, the proton is a charged body and the neutron is, it is not a charged body. Okay, electron is negative charged body. You can see in the picture structure of the atomic nucleus, protons, neutrons, electrons, where they occur. The first we come to the protons. So where there are protons here in the middle. Here it is a neutron, empty circles are neutron, and where I written the positive, these are protons. Here atoms are made up of extremely tiny particles, protons. Okay, they are made up of small particles called we say that protons, and neutrons and electrons. Here protons and neutrons are in the center of them. They are center of them, making, what is that? They are making the nucleus. What is that? Nucleus. So electrons, they are surrounded. Protons are positive and electrons are negative. So your particles electron E minus, charge -1. Okay. Proton C plus, it is +1. Neutron, there is no any charge body, it is 0. Okay. The mass you can see that. The mass of the electron 9.109382, something is there. You can just see it. This is the mass of the electron, proton and neutron. Now we come to that rules determining the number of subatomic particles. Subatomic particles is protons, neutrons and electrons. The number of protons, electrons and neutrons, electrons in an atom can be determined from a set of simple rules. Okay. So the number of protons in the nucleus, the atom is equal to the atomic number. Okay. Atomic number. Okay. The number of protons in the nucleus of the atom is equal to the atomic number. Okay. So what is the atomic number? We know that atomic number of all the elements. Right, it is equal to the nucleus. The number of electrons in a neutral atom is equal to the nucleus of number of protons. What is that? The number of electrons in a neutral atom is equal to the number of protons. The number of the atom N is equal to the sum of the number of protons and neutrons in the nucleus. The number of neutrons is equal to the difference between the mass number of the atom and the atomic number. It is difference is there. You know, somewhere it is said somewhere it is double, somewhere it is double plus also is there. So just come to that, what is the difference between protons and electrons? What is the difference between protons and this one electrons? So protons have positive charge and electrons have negative charge. Okay. So protons are significantly they are heavier. The mass is more. Here electrons are comparatively light in weight. Okay. Here protons are larger in size. So protons will be in the larger in size, electrons will be smaller in size. Protons remain in the nucleus. Okay, protons will be remain in the nucleus. Electrons can move to the other atoms also. You know that what we have discussed students, it will be having the formula, the structure of the atom. What is that? So it is a nucleus plus plus minus minus no, this is neutron. There is no end. So I told you that. So you can see this. So I told that n is equal to 1, n is equal to 2, n is equal to 3, and n is equal to 4, which is k, l, m, n, right? So what the formula we find is to put electrons 2n star. So if n is 1 in this position, the first charge body is there. Okay, so 2n star is what I said, students, it is 2. So it is only two electrons should be there today. If here only 2 electrons should be there. If 3 means it goes to the next body. Okay, it goes to the next cell. So these are the cells. Okay, these are the cells. The first cell, second cell, third cell, fourth cell. In the first cell, there should be 2 electrons. Here, there should be 2 electrons. And come to the second cell. So 2 into 2 star is equal to what we say that 2 into 2 means 4 is equal to 8. Here it should be only 8 electrons. If 9 means this electron goes to this cell. Understood? So it moves to the next. Protons and neutrons will be constant. Okay, they will be not staying their place. It will be fixed in the center position of an atom. Here, so here what I said that 2 electrons should be there in this. For example, you take the element, any element which is having the more than 2 electrons. You tell me which is having four atomic number, students. Which element has 4 atomic number? Which electron has 3 atomic number? Which element has 3 atomic number?
Lithium.
Lithium.
Ganesh,
Yes, lithium. So lithium has atomic number 3. Then here we take the lithium, we have to represent in this structure means only we can represent 2 electrons and another one we are moving to this cell. Well, because it is fixed, only 2 electrons should be present in this. If more are there, it should go to here. And come to the next one here, how many should be present? 8 should be present. You tell me which is having 9, any electrons should be having 9 atomic number? Which is having 9, atomic number 9? Eight. Which atomic number?
Fluorine.
Fluorine. Yes. Fluorine is having a 9, atomic number 9. Some years produce. 9 means 43 years. First we come to here 2 and here 7. Okay. Here 2 and here 7 electrons. Okay, it is 9. Then 9 plus 2 is 11. Come to the 12 electrons. 12, which is having 12. Which atomic number 12 has
Magnesium.
magnesium. So you know magnesium Mg having the 12. Now you see that here 2 electrons, here 8 electrons means 12. Remaining where it should go? Third cell. What is that? Third cell. Now here 2 and here 8 you can take electrons 8 and third cell how many should be present? 2 into 3 whole square, 2 into 9, 18 should be present. Here 18 electrons should be present. More than 18, we shift to the next cell. Understood, students? Understood?
Ma'am.
Yes, ma'am.
Okay. So this is the what is the protons and neutrons. Protons are present in the nucleus cloud. We say nucleus cloud is the center point. This is called what it has neutrons and protons. That is called nucleus. So electrons are present in cells. So electrons are present in the cells means this we call it as the cell. Okay. Next. See, a Rutherford's model of the atom is there, students. Consider textbook. There is a scientist called Rutherford model of an atom. Okay. Who is this? Here J.J. Thomson is there. Here J.J. Thomson, British physicist, was born in Seatham Hill, suburb of Manchester on 18 December 1856. Okay, what he discovered? So he discovered of electrons. And the Rutherford's model of an atom is there. It comes to here. So what is this Rutherford? So Rutherford is a scientist. Okay. He allowed a beam of fast moving alpha particles having positive charge to fall on a thin gold foil. He observed that. What he observed that? Rutherford allowed a beam of fast moving alpha particles. So beam means what is that? We say beam of light, right, students? Have you heard that beam of light, students?
Yes.
Yes, no?
Yes.
You can see the students. So when you pass the beam of light on the gold, okay, or the what is that? Any object like metals or steel. So what happens, students? There, okay. When you put a light on the metals like gold, okay, they shine. What happens? They shine, friends. Yes or no? They shine. So
Yes, ma'am.
they are having positive charge. Why? Because positive charge, they fall on a thin gold foil. They have alpha particles, fast moving alpha particles having positive charge to fall on a thin gold foil. So most of the alpha particles pass straight through the gold foil. Pass straight. The light pass straight, and some of them slide. Some of the light that passes, the beam of light passes straight. Some of the slightly means you can see the light and slight means slanting lights and all like this, triangle lines. And very few particles appear to rebound. Rebound means, so which are showing you like rebound means just went light and come back. Okay, so this is we call as rebound, and some of the alpha particles reflected by the small angles, and most of the alpha particles pass straight through the gold side. So what is the conclusion from Rutherford's alpha scattering experiment? What is that? So most of the space inside an atom is empty. Most of the space inside an atom is empty, students, because most of the alpha particles pass straight through the gold side. So whenever the space empty is there, the light passes straight. Right, students? You can see here. You see here the place is empty. Place is empty. Place is empty. So that's why you can see the straight lines. So this is an atom. You can see the most of the space is empty. That's why the light is passing straight. It is representing with a straight line. So the atom has a small nucleus having positive charge. What it has in positive charge? So it has a nucleus. It has a positive charge in the center of the cell. So these because some of the alpha particles having positive charge, they are slightly deflected by small angles. So which are having slightly deflecting small angles like this, they have some. So these is called a positive charge body. This type of lines represented, they are positive charge body. The size of the nucleus is very small compared to the size of the atom. So atom is a big structure. Atom is big structure. But nucleus is a part of the atom. Nucleus is a part of the atom. Remember, small size we can represent the atom. That is what, because very few particles appear to rebound, and most of the positive charge and mass of the atom in the nucleus. This is what represent of the atom, structure of an atom. So atom has a positive charge nucleus as its center, and most of the mass of the atom is in the nucleus. Most of the atom will be in the nucleus part only. Why? Because positive charge will be having the more height, more weight. Okay, compared to the neutrons, protons having more weight. Okay, the electrons revolve around the nucleus in different orbits. In different orbits means what is that? So this is one orbit, this is one orbit, this is one orbit. These are the orbits. Okay, the electrons present in these orbits. Different orbits means the first cell we represent 2 electrons, second cell we represent 8, third 18, fourth 36 electrons. They have what is that? Electrons revolve around the nucleus in different orbits. The size of the nucleus is very small. Because the nucleus is small, I told that the part of the nucleus is a part of an atom compared to the size of the atom. See, defects of Rutherford's model of the atom. What is this defect? You can see the structure of an atom source, which is you can see Rutherford's model of an atom. So lightly charged electrons in orbits around the nucleus. and very small positively charged nucleus. So this is showing the negative, it is negative charge bodies surrounded the nucleus. Okay, the positive charge body is center of the cell. Here you can see that any particle in a circular orbit would undergo acceleration, and during acceleration the charged particle would radiate energy. So the revolving electrons would be lose energy and fall into the nucleus. So is that, and the atom would be unstable. We know that atoms are stable. Atoms are stable, but here what happens, students? There will be positive charge bodies and negative charge bodies. So atoms scale here, atoms is there, protons and electrons are there. Here atoms can lose or gain, we say that, lose or gain electron. What is it? Electrons. Lose or gain. Here is the electrons. Here first cell, it should be 2 electrons. Should be present 2 electrons. If a methane has 3 atoms, means it may lose 1 electron here. It may lose 1 electron in this concept, I can say. Lose. Gain means it goes to the negative and positive. If 3 electrons is there, means electrons, it goes to here. Okay. Lithium has 3, so 2 electrons will be present in the first cell. It goes to the positive, the protons gain these electrons. The neutrons, electrons lose this. Now you write the class first. Charged particles in matter. Atoms have 3 types of subatomic particles. They are electrons, protons, and neutrons. Neutrons, protons, electrons, from C plus. Yes, ma'am. Have you completed, students?
Yes, ma'am.
Yes, ma'am.
Okay. Tomorrow I'll send the last lesson. Today I'll send that class work. Pair work I'll send. Okay. Exercise part question 6 I'll send today. How many questions are there in the last lesson? Total 11 questions are there. And some of the questions given the students, you try to do it. What is that? What is the mass of 1 mole of nitrogen atom, 4 moles of aluminum atom? Some are easy only. Are there? You just practice that. Some problems are there. I will tell you. And exercise part, which one I have to send? Which I have discussed that I will not send. So which one I have not discussed? Page number 35 and page number 32 and 33. These two. Only three chapter-wise questions I have to send. Okay, if you will send, you write it in your fair number. Okay, sir?
ಏ ಸಕ್ಕತ್ ತಗೋ ಇನ್ನೇನ್ ಗೊತ್ತಾಗಿರ್ತಿಲ್ಲ